Hello, my name is Luke Bodwin, Systems Engineer at Texas Instruments and Development Lead for the HET IDE, which is the development environment for the 32-channel timer coprocessor, high-end timer, or HET, implemented on the TMS 570 microcontrollers. The HET is a programmable, extremely flexible timer that can be used for traditional or complex timing functions, such as pulse width modulation, input capture, or input compare. It is very useful for a wide range of applications such as motor control. The IDE, Integrated Development Environment, has been designed to ease and accelerate the development and debug of high-end timer code. The HET IDE ships with the TMS 570 Development Kit DVD and is available for free download from the Texas Instruments website. Now let's take a look at the IDE in edit mode. It contains a project window and a code edit window. The first thing to do to start developing and debugging HET code is to create a project. To do this, you will need to select the TMS 570 device that you are using, then your clock frequency, and finally the two ratios used for the generation of the high-resolution clock and the loop resolution clock. Please refer to the technical reference manual for more technical details regarding these clocks. By right-clicking on the project, you can select and save the setup properties. Once a project has been created, your HET code development can begin. HET assembly code can be generated in three different ways. The first way is to directly write code in the editor window. The HET code editor provides color coding to ease the code development. The second way is to use a drag and drop feature from the edit menu. The instruction drag and drop covers the complete 96-bit instruction set of the high-end timer and displays all mandatory or optional fields. Mandatory fields are highlighted in red. The instruction is assembled at drop time to ensure the proper syntax is followed. Finally, the third way to develop code is by using the algorithm library. The library contains the most commonly used algorithms such as pulse width modulation, frequency and pulse measurement, or input edge counter. The algorithms can be customized for your needs using predefined variables. Once a project is defined and the code is loaded in memory, the IDE switches to run mode. Now let's take a look at the IDE in run mode. The graphical user interface offers the possibility to set breakpoints on memory lines by simply double-clicking in the disassembly window. A special utility is provided for complex breakpoints occurring on pin transactions or on HET memory field comparisons. In order to ease the debug effort, Texas Instruments has partnered with SynapticCAD to provide a real-time display of the HET signals. The HET signals consist of the I/O pins, but also of the registers, internal registers, or HET memory fields. In run mode, both the high-end timer and the waveform viewer are synchronized. This provides the possibility to visualize signals or memory contents on a cycle-by-cycle basis while the simulation is running. The IDE also offers three different ways to provide input stimuli. Input stimuli can be generated by using SynapticCAD's Waveformer Pro, by inputting a VCD file, or by the input stimuli utility. The IDE has been designed to work best in conjunction with SynapticCAD's Waveformer Pro. Waveformer Pro can be used to draw input waveforms to drive the HET simulator. Waveformer Pro can also create timing diagram documentation or import waveforms in many formats used in the industry. As a high-end timer user, you will get a free 90-day license from SynapticCAD. Without a license, you will still be able to use the SynapticCAD Wave Viewer, which is installed with the IDE for easy waveform display. However, you will not be able to build input waveforms using the tool. Additionally, the IDE offers the possibility to input stimuli by inputting a standard VCD file. VCD is a standard format representing waveforms. It is used by a wide range of tools, from simulation tools to logic analyzers or oscilloscopes. Inputting a VCD file with the proper signal names properties will result in driving the pins to the HET simulator. Another possibility is to use the input stimuli utility, which gives a graphical view of how to create pin transactions. Input edges can be created based on either clock cycle or the absolute time. For more information on the HET IDE, please visit www.ti.com/TMS570. For a free download of the HET IDE, please go under the Tools and Software tab. Make sure you also download the technical reference manual with all relevant technical information regarding TI's high-end timer. Thank you.